Hey, Algebra 2, we're working more with some other concepts, but now we're going to go ahead and start inequalities with absolute value. Our essential question, can you solve open sentences involving absolute value? The first thing we need to define is what is absolute value. Remember, it is the distance a number is from 0. So remember, the distance can go into the negatives or it can go into the positives. So I like to teach this absolute value with a plus and a minus. Our directions are telling us to solve and graph. The way we're going to write example 1 is we're going to write everything from the right side over. Well, first we're going to write it totally the same, and then we're going to write it with everything from the right side over. If it's an inequality, we'll flip it, and all the signs will change. So for example 1, I'm going to write it, I call it a plus and a minus side. I'm going to write it the exact same way. 2s plus 3 is equal to 5. And then the other, I'm going to write everything over here flipped. 2s plus 3 equals negative 5. So now we're just going to go ahead and solve these. If I solve these, I'm going to subtract 3 first. I'm going to solve the left side first. 2s is equal to 2, where s is equal to 1. Solve on the right side. 2s is equal to negative 8. S is equal to negative 4. So I'm going to have my number line. Typically it's provided for you. I'll show my 0, 1, 2, 3, negative 4, and a positive 1. When it is an equal, we're just going to show it with a closed circle. And there is my solution. Now, let's go back and check our two solutions. If I was to check, we should check all of our work. If I was to check 2 times 1 plus 3 absolute value, is that equal to 5? Yes, it is. What about 2 times negative 4? Negative 8 plus 3 is negative 5. Is that equal to 5? Is negative 8 plus 3 equal to absolute value of 5? Yes, it is. So it's always a good idea to go back and check your work. Always, always a great idea. All right, let's move on to example 2. Example 2 has one of those inequalities. So remember, we're going to take everything from here on over and flip the inequality and change all the signs. If I had to write it as a positive and a negative, I chose positive and negative because it, I don't know, it's just easy to remember. Positive and negative, because you have to go to the left and to the right. 3 minus k is less than 2. So remember, it will be written just like you see. And the other will be 3 minus k is greater than negative 2. So this is what we're solving. When I subtract 3, I get negative k is less than negative 1. And don't forget, when I divide by a negative, I flip the inequality. When I subtract 3, negative k is greater than negative 5. When I divide, k is less than 5. Let's go ahead and graph. I have 1, 2, 3, 4, 5. Again, the number line is typically provided for you. We're going to put an open circle at 1, going greater than, an open circle at 5, going less than. So this one does connect together. All right, we're going to move on to this. I didn't get to this in class today, but hopefully you guys get a chance to watch the video. All right, we're going to get going. Remember, on the absolute value, this is the inside of the absolute value. Well, in order to solve these, we need this absolute value all alone. So the first thing I have to do is I have to get rid of the numbers that are not in the absolute value. So for example, this 7. How do I get rid of that 7? Good. I'm going to subtract 7 over. And I have negative 3 absolute value of 4x minus 7 is greater than or equal to -3. I still have to get rid of everything around, so I need to get rid of this -3. Good. I'm going to go ahead and divide. When I divide by a negative, I have the absolute value for x minus 7 is less than or equal to 1. So now this is what we're working with. From here, we're going to write our plus and our minus. I'm going to write it, I'll just write it right over here. I'll make it larger so we can see it. So I'm going to write it exactly the way I see it. 4x minus 7 is less than or equal to 1. And then remember, I'm going to change everything from here over. So 4x minus 7 is greater than or equal to -1. And that's what we're solving. Let's solve. When I add 7 over, 4x is less than or equal to 8. X is less than or equal to 2. Add 7. 4x is greater than or equal to 6. X is greater than or equal to 6 over 4, but remember we have to reduce that to 3/2. This is a fun one to graph because 1 and 2, or 1.5 and 2 are very close. So I'm going to show my little halvesy. If x is less than or equal to 2, I have a closed circle on 2 going to the left. If x is greater than or equal to 3/2, closed circle going to the right. All right, I have one more that I want to go over. This one. What happens when I have two absolute values? So this could get really, really confusing. We're going to do the exact same thing that I told you to do. So from everything from here on over, we're going to flip the inequality on the second one and change all the signs. Don't freak out about the absolute value. We're going to just look at the numbers. So the original, I'm going to write as 2x is less than or equal to x minus 3. The new one, 2x, we're going to flip the inequality, greater than or equal to, and we're going to change all the signs, -x and a +3. When we solve on the left side, we're going to subtract x over. X is less than or equal to -3. We're going to add x over. 3x is greater than or equal to 3. X is greater than or equal to 1. Now, this is the point where you really have to be right on. All right, so let's talk about this. In order to actually graph this, this is the part that I really, really check. And this is the part where we're going to find our information. I have 0, I have 1, -1, -2, -3. Now, my two solutions are here and here. So what I tell my students is we have to pick a number. So I'm going to pick a number in this area right here. Actually, I'll put an arrow. What number is less than -3? Good, -4. So over here, I'm going to take -4 and plug it in. 2 times -4, absolute value, is less than or equal to, and let me pull this back down here. We are plugging it back into the original. -4 minus 3 absolute value. So inside this absolute value is -8. Is 8 less than or equal to -7? +7 because it's absolute value. No, this is not a true statement, so I'm not going to show in this area right here, I'm not going to show any lines, none at all. All right, now let's try for this area right here. I'm going to plug in, well, I'm going to plug in 0 because that's the easiest number to plug in. But you know what? I'll plug in -1. If I plug in -1, notice I'm plugging it into the original. 2 times -1 is the absolute value of -2 less than the absolute value of -4. Sure, 2 is less than or equal to 4. So this area is going to be filled in, that whole area. Now I'm going to check this area. So again, I'm going to pick a number greater than 1. I'm going to make it easy, and I'm going to pick 2. So I'm going to plug 2 in. 2 times 2 is less than or equal to 2 minus 3. And 2 times 2 is absolute value of 4. 2 minus 3 is negative 1. Is 4 less than or equal to 1? No. So right here in this area, I am not going to graph anything. So from the conclusion, from looking at the graph, I know that negative 3 is less than or equal to x, which is less than or equal to 1. So this right here that I am circling in yellow is my full answer. The way we get the answer is by actually, if we have 2 sides of absolute value, we have to plug in and check every single area. Great job.